Can you hear me well? Yeah. So the title is a bit of a lie because we will not have time to cover everything, but we will cover a few things. So I'm Hadrien. You may know me as one of the developers of OpenZeppelin Solidity contract. Yeah. We just released our version 5.5. I hope you like it. I hope you can try it. We put a lot of effort into it and a lot of our heart and our energy in doing new interesting things. So the OpenZeppelin contract is something that is built and designed by Solidity developers. Everybody in the team has some experience in doing Solidity development. We love going to hackathons and so on. And it's developed for Solidity developers, for you guys. But most importantly, it's developed and implemented in Solidity. That's one of the key features of our library that maybe separates it from others, is that we take a huge importance in the fact that what you are building is actually built in Solidity so that it can easily be audited, reviewed, so that you can understand, and so you can use it as a tutorial on what to do and what to not do. But are we really writing it in Solidity? Last time I checked, not really. Like, this is an example of a proxy contract, like our base proxy. And you'll see this big chunk in the middle. That's not really Solidity. That's assembly. That's Fuel. And I think that's fine to have some of it. But over the library, we have 400 of these blocks. I mean, most of them are procedurally generated because we don't have generics. So it's not that bad. But it shows something. It shows that there are things that the EVM is able to express. There are things that the EVM is powerful enough to do that the language doesn't give us access to. And we have to bypass the language, we have to bypass the Solidity to go lower, to go closer to the machine, not directly into bytecode, even though sometimes we do that, but at least going one step below. And so I want to go over like why do we use assembly? Where are the places where the language is not good enough? And would we be able to improve the language so that we don't need to resort to assembly? And maybe Solidity Core is part of the answer. I hope so. But let's go over that. So the most important part, I think, is for low-level calls. Because in native Solidity, you can either do a basic call, and if there is a revert, the revert reason is bubbled, and that's fine for possibly 95 to 99% of the use cases. And when you don't want to do that, you can do a try-catch. And the try-catch is quite nice, but the try-catch will fail, and not catch, like actually fail, if the target is not a contract. And so if you want to use that on arbitrary addresses, you have to check that the contract is not an address first, implement some kind of fallback, and then Solidity will recheck the same thing, and it's a nightmare. And we also have the low-level calls, which are Solidity's like solution to go low-level, but even those are not great. First, I mean, you have to encode the inputs, and encoding means allocating memory, and we'll see that that's an issue a bit later. And also, like, the result we get are in memory, and that means we expand the memory even when we want to discard the results. And overall, like, those are nice in many cases, but when we want to do something like super optimized, when we are chasing every single bit of gas because this is going to be used by possibly everybody in this space, then our best option is to go low level. And as much as I would love this safe transfer function to be written in Solidity, native Solidity, we've tried our best, and there is just no way around it. Like, writing it in YUL is just more effective, and it's way less readable. So we have to do some choices here, and our choice was to go against readability and into performance. And I think that's a bad consequences of the design of the language. So this is something I think should be done better. And I don't have any proposition on how to do it better. I think it's very hard to do. It's just, yeah, this is somewhere where the language is not ideal. And then we go into memory. Memory is nice. You've seen it can be used to go around stack to deep error, but memory is, even though like a single mstore or mload are like basically cheap or free, like 3 or 5 gas, so basically insignificant, what's expensive is allocating memory. And this is a piece of code that we have in one of our governor, what I found while preparing these slides, where we actually have a for loop, and inside the for loop we compute a hash doing an ABI encode. Yeah, here. And this ABI encode will allocate memory, possibly a lot of memory. And just in order to hash it. So after it's been hashed, we don't care about it. But the thing is that unless we have this special call to our memory library, Solidity by default, we just keep the free memory pointer moving, and we'll do that over and over the for loop. And even if like actually doing one encode might not be that expensive, expanding the memory over time, this is really bad. This is going to hurt your gas costs. And Solidity doesn't know whether this value is going to be reused or not. So it's assumed for the worst case, it assumes it's going to be required. So it's going to reserve the memory and move the free memory pointer. And there is currently no way in the language to say, oh, this buffer that I'm allocating, I want to deallocate it. And when you want to deallocate it, you want to deallocate it fast. Because if you don't do it fast, then other stuff is going to be put after that position in the memory, at the free memory pointer. And it would make, you won't be able to deallocate it anymore. Because the memory in Solidity is just linear. I mean, not in Solidity, in EVM is linear. So that's bad. So yeah, ideally, we would have a language that would support better memory management, maybe using like, I don't know, maybe modifiers or annexation, like status from the type, keywords on the type saying like, please deallocate that and deallocate it fast. There is a bubbling revert. With Solidity, you are able to revert with custom errors. This is great. Thank you, Solidity, for adding that. You can also revert with nothing or with a string, but sometimes you just want to bubble the return that you got before. Solidity, we do that by default when you just do a simple call. But if you do a try catch and you want to look what is in the catch, and in some cases you want to process it, in other cases you just want to bubble it, Solidity doesn't provide you a way to bubble a byte. Like you could, if you start reverting with a bytes object, Solidity will encapsulate that inside an error byte, which is basically the first custom error that exists, the custom error that is used for everything that is not a custom error, actually. Maybe it's a string, we have to check. So we do that in assembly. We do that quite often. Honestly, like, adding that to native Solidity would be a no-brainer. I think like if we were doing that in Solidity core, it would probably be a 2 or 3 line function, but we don't have access to that by default. Maybe it's something OpenZeppelin could provide. Let's think about it. But in that case, it's a bit particular because we are returning something that we haven't even allocated properly. We just put that on the memory, and this is not memory safe. Decode call data. Okay, sometimes we want to ABI decode stuff. Solidity lets us ABI decode objects that are in memory. If you provide a call data object, it will be put in memory first. And if the ABI decoding fails, you get no way to catch that. That's one of the things that we think is really bad. We would like to be able to catch it. Maybe in Solidity core, we will have a generic type, an algebraic type for that, and that will be great. But sometimes we also know that the input will be in call data, and we just want the output in call data because we don't want to allocate memory because memory is so expensive to allocate. And so what we want is we want to take the object, like go deep into like how it's encoded, and this is always painful to do. So if Solidity could do it natively, it would be better. And even if we do it ourselves, in the end, we still have to create the call data object. And the call data object is basically a pair of integer, which is an offset and a length, a position, like a slice in the call data. But like even if we wanted to do that in full like native Solidity, we have no way to do that last block without going to assembly. So yeah, I mean the best option would be to have an ABI decode call data natively, but we don't have that. Emic panic code. So that's going back to the revert things. Like there is not just revert like a custom error and so on. There are panic codes, and panic codes are great because panic codes are explicit about what is failing. If you try to pop an array that is empty, it will tell you it's not possible. There is no item to pop. If you start like doing like division by 0, there is a panic code for that. When you do checked arithmetics and you check for overflows, those are the panic codes that are emitted, and we want to use them. We want to use them when we build our own data structures that are not native to Solidity. Maybe at some point they will be generic in Solidity core. I'm really hyped by that. But that sometimes like we're trying to pop something from a queue and the queue is empty, well, we want to panic. And so the panics are native to Solidity, but they are reserved to like the compiler level stuff. As user, we cannot emit them unless we do it manually in assembly. So that's what we do. But ideally, maybe it's best that OpenZeppelin provides that for everybody, but I don't know, maybe the language should allow us to do that. Unchecked access, okay, this is something. Because you know the unchecked keyword is for arithmetics. It tries to remove the checking for like multiplication and addition and subtraction overflow. Divisions bar 0 are still checked. Like even in an unchecked block, if you try to divide by 0, EVM will return 0, but if you do it in Yule, you'll get 0. But Solidity will give you a panic anyway. And what Solidity will also do is that when you do a lookup on something that is an array, like a by32 storage array like that, if you start accessing it in Solidity natively, Solidity would first load the length of the array, check whether your index is within the bounds of the length, and if it's OK, it will return the value, otherwise it will panic. The thing is that sometimes you want to do a for loop, and you want to go over the entire array, or even if not the entire array, a large section. And so every time you go over to you look the next value, it will redo the check, even though like we know that the length is OK, but Solidity doesn't know that because Solidity doesn't have the high-level logic of this loop. And so they will check every time. And every time they check, they have to load the value from storage, which even if it's a hot value that has already been accessed, it's 100 gas, plus do a if to compare it that's maybe 30 gas with a panic code that hopefully won't be emitted. And when we know that by design that the loop is, the bounds are correct, well, we want to skip this checking, and unchecked doesn't do it, so we have our own implementation that does that. And yeah, it's a bit of a pain to do this unchecked access ourselves, because we have to compute like the position in assembly. Like it's a bit of a pain, but we do that anyway, and we're saving a lot of gas with that. So again, going back to Solidity core, maybe we can have a container algebraic data type with like a for each function that will feed you all the values one by one, and it knows that it's in bounds, so there will be no checks, but we don't have that today. So today we have to do our way around it. And it's not ideal because here like it's not actually fully memory safe when we load from memory, because like in most cases if the input of that functions are okay, then it's memory safe. But with that function alone, if you don't have the call context, you cannot know whether it's memory safe or not. Chunks of bytes. Yeah, if you have a byte buffer like this is a huge, like basically a huge buffer of data, and Solidity lets you access it one by one, like 1 byte by 1 byte. So one value between 0 and 255, one by one. But memory words in EVM are 32 bytes, so you could go 32 times faster by loading them as chunks. Solidity lets you do that with call data buffers, but not with memory buffers. So if you want to go fast and have this loop go like 32 by 32 instead of 1 by 1, which goes much faster, then you have to read the buffers yourself. And again, this is a bad example because previously I said that this was not memory safe, and this should, for the same reason, not be memory safe. But here in that case, the function is private, and so we control when it's being called, and that's how we make it memory safe. But that means this function is probably declared 3 or 4 times in our library because we don't want to make it available, and so we have to put it privately wherever we use it. Transient structures. Okay, so I mean, Solidity is moving and added transient value types, which is already good. But as far as I know, most of the usage of transient values, like in Uniswap v4, are more complex objects than just that. Like they use mapping. They use. Honestly, I want to do enumerable set in transient storage. I want to do DQ in transient storage. We would actually have use cases for that, and right now we cannot. So in some cases, you can like use our libraries. We have derived mapping function. We have the tstore library. When you combine all of that, we're able to mimic mappings and things like that with transients in the transient space. So we have a way to go around it, but it's not ideal. And in particular, like all the structures that we would want to build, like big enumerable mappings and things like that in transient storage, we cannot build them right now. I mean, it would be a nightmare to build them, and I think the language should hopefully support that. I'll have to see how Solidity core handles transient object. Maybe the standard library will have to deal with that anyway. So, I mean, I don't want to say that things are trivial or hard, and it really depends on how you want to do it. But there are really low-hanging fruit here. Maybe the transient structure is, I mean, I'm saying it's a low-hanging fruit. I tried modifying the compiler. It was a pain. But honestly, it should be a low-hanging fruit because there is no more logic to invent. I think the main reason why transient structure were not implemented early on by Solidity team, maybe Solidity team will contradict me, or the Argo collective will contradict me, but I think the reason why that when you use normal storage, you try to pack stuff a lot to save on slots. And in the transient phase, maybe it's a waste to pack too much. Maybe you want to expand a bit more because the storage slots are not that expensive and the packing has a cost. But honestly, like I'd rather have something that is packed for no reason than have nothing. Also, since it's transient, if you change the logic later, you don't have to keep the same structure because it's erased at the end of every transaction anyway. And there are things that I think would be easy. Maybe they are not. Maybe Solidity has a good reason to do it. But I think it should be decently easy to do. And there is stuff that is hard. Like low-level calls, I have no idea how to fix that because the expressivity of the language would have to be very, very complex for all the use cases we have. And the deallocation of memory, it can be quite easy if the user lets the compiler knows when to deallocate, and the compiler just blankly traces the user, and if the user messes up, the code is messed up. But if the compiler wants to do checks or do it automatically, this would, I think, be very hard. So, yeah. So, can Solidity Core help? I've mentioned Solidity Core a while in this talk, and with all the information from this morning, I want to mention it even more. I really hope that it does. The thing is that everything I mentioned is stuff that we do having access to YUL. So if we can do it today having access to YUL, there is no reason why a standard library in Solidity Core could not also do it. And I think with algebraic data types, we are able to have a control over the flow of the execution. And also with lambdas that have been mentioned, we can do stuff that I think would be really useful. So I'm really, really hyped by Solidity Core, and I hope it gives us an opportunity to contribute to the standard library, or to, I mean, I would even be ready to take care of the standard library if that helps the community and really do things right and have a language that is more readable and more efficient in terms of gas. That's everything I've got for you today. I'm open to any questions.
Thank you so much, Hadrien. As I read out some of the questions already trickling in, more questions you can post using the session QR code. When OpenZeppelin standard library?
So if it was up to me, I would have started 4 years ago when you announced in Amsterdam. No, but more seriously, I would love to work on that. But as was mentioned earlier today, this should be a community thing, and I don't know how it will be governed. I think the governance of the standard library will be a major thing we'll have to fix in the upcoming months and years. But I personally want to commit all my energy and possibly OpenZeppelin's energy to being part of that effort. It's really something we want to do. But we don't want to exclude, I mean, we should not be able to exclude anyone anyway. So obviously everybody will have to be welcome and will have to deal with how decisions are being made.
Any more questions for Hadrien? Any from the crowd? Okay. Well, thank you so much. That was a wonderful talk. Please give it up for Hadrien.